topic today is weighted arithmetic mean. At the end of this class, you'll be able to compute the weighted arithmetic mean and solve problems related to weighted arithmetic mean. For instance, your grade point average as a student, if you want to compute your grade point average with good understanding of the weighted arithmetic mean, you are going to do that seamlessly. We are going to show you examples. Thank you for being with us. My name is Dr. Twane. Please do well to subscribe to our channel, share our videos, like our videos. God bless you. Now, in our previous class, we extensively discussed the arithmetic mean. And we told you that the arithmetic mean of a set of numbers is the summation of those numbers divided by the number of times they occur. Now, when you do that, the importance are equally distributed among the items. For instance, if you have the scores of 5 students in an examination, say these 5 students are rated over 100, and the first student scored 15, the second student scored 20, the third student scored 35, and then the fourth student scored 85, and then the fifth student scored 95. Now, if you look at this scores of students, this is 15 over 100, 20 over 100, 35 over 100, 85 over 100, and 95 over 100. Now, if you are asked to calculate the arithmetic mean of this, the arithmetic mean, as we told you previously, will be x bar is equal to, we have summation of xi, as our I goes from 1 to n all over n. And that will be equal to, so we now look at the values. The first value is 15, plus the second value is 20, plus the third value is 35, plus the fourth value is 85, plus the last value is 95. All of that over, how many values do we have? 1, 2, 3, 4, 5. That's our n, all over 5. And so that will be equal to, this is 35, 70, 155, and then 250. So we have 250 all over 5, which is equal to 50. Now, if you have 50, it means the average or the mean of this score is 50. The implication of that is that the students did well in the examination because the average score is 50. However, if you look at the values itself, you see that one person scored 15 over 100, which is a failure. This other person scored 20 over 100, which means the student also failed. This person scored 35 over 100, which means the student also failed. And if that's the case, it means that 3 students failed. 85 is a good mark. 85 over 100, 95 over 100. These 2 students passed and 3 students failed, which means the result is not a good one. But if you look at the arithmetic mean, the value of 50 is indicating that the result was good. And so that's one of the limitations of the arithmetic mean. When that happens, it means that somehow the weighted arithmetic mean is preferred over the arithmetic mean. Again, sometimes you see values occur with certain weights. And so when these values occur with weights, now the arithmetic mean is not as good as the weighted arithmetic mean. And so what I mean is this. Sometimes these values occur with certain weights. For instance, we may have x1, x2, x3, and that will continue up to xn, occurring with weights as, call it w1, w2, w3, and it continues to wn. Okay? So in that situation, we'll say that our weighted arithmetic mean is equal to, so we'll now have the weight, which is our w1 times the value itself, x1, plus the weight again, W2 times the value itself, x2, plus the weight again, W3 times the value itself, x3, plus it will continue to plus this Wn times the value xn. All of that over now the sum of the weight, which will be W1 plus W2 plus W3 plus it will continue to plus Wn. Okay, so we can actually summarize this or write it as, say, x bar W, which is our weighted arithmetic mean, as being equal to, so we have, because of this summation that we are doing here, we use our sigma and say summation Wi xi, as our I goes from, this is 1, 2, 3, up to n, as I goes from 1 to n. All of that over the summation of our W. We have Wi also as our I goes from 1 to n. However, don't be bothered about this subscript. You can actually write this without the subscript to say simply that this is equal to summation of what? Wx all over summation of W. Okay? So if you can do that, it's also fine. Now, let's look at an instance. In a semester examination, now, these are the courses offered. These are the courses offered. Now, these are the units. And then, let's say the scores of students in examination. The scores, call it grade. That the scores in Maths 101, that is 4 units, the students scored A. In Star 101, the students scored B. In Physics 105, the students scored C. In Chemistry 101, the students scored D. In Bio 101, the students scored E. And in GST 111, the students scored F. Now, what is the student's GPA? Grade point average. So, by virtue of computing your weighted arithmetic mean, you have also computed your grade point average. So, if this, as it is your score in a particular semester, now let's see what your grade point average is. Now, what we do, firstly, A is graded as what? 5. Okay. B is graded as 4. C is graded as 3. D is graded as 2. E is graded as 1. And F is graded as 0. We are considering 5-point grading system. And so that will mean that our Wx, note that our weighted arithmetic mean is equal to summation of Wi xi, as our I goes from 1 to n, all over summation of Wi as our I goes from 1 to n. Note that. So our Wx is this other one. So now the unit, which is like the weight, unit is the same as the weight of each of the courses. So you see that sum, the weight of sum, you have 4, 4, 4, 4, 4, and the weight of this is 3. So most times the weights are not always the same. So 4 times 5 will be 20. Now 4 times 4 will be 16. 4 times 3 will be 12. 4 times 2 will be 8. 4 times 1 will be 4. 3 times 0 will be 0. So that the summation of our Wx will be equal to, if you okay, so the summation of our WX will be 20 plus 16 will be 36, 48, 56, and 60. So this is 60. And then the weight 4, 8, 12, 16, 20, 23. So this is 23, which is the summation of our W is equal to 23. So the next is to just substitute these values. And if we do that, this will be equal to exactly 60 all over 23. And if you divide your 60 by 23, what will it give you? 2.61. Okay? 2.61. So it means that your GPA for that particular semester is equal to what? 2.61. That's if this is your score. So that's part of how we use the weighted arithmetic mean. Now, the question can come in a different way. Because you now have an idea, you now know how to calculate your weighted arithmetic mean. There could be a situation of missing value. For instance, here, probably say in physics, you don't know what is called in physics, but you know what is your GPA for the semester. Right? And you are to do what? Calculate to look for that missing value. Now, let's take an instance. A student's result in a semester is presented below. If his GPA in that semester is 3.0, what is his score in star 101? Now, this is a score of the students in the semester, and the result in star 101 is not known. We call it missing value. However, we know that the GPA is equal to, we are informed that the GPA, which is like the weighted arithmetic mean, is equal to what? 3.0. Now, what is the score in star 101? Now, the score that we don't know, let's say that score is Y. Let's call it Y. The missing value we are looking for is Y. Now, in that case, note that often our A, since we are considering a 5-point scale, our A is 5, our C we know is 3, D is equal to 2, E is 1. So that our WX will be 4 times 5, 20. We don't know this, so 4 times Y will be 4Y. 4 times 3 will be 12. 4 times 2 will be 8. And 4 times 1 will be 4. Now, the summation of the unit, 4 plus 4 plus 4, 5 times is 20. And then this is 20. We can't say 20 plus 4y because we don't know what the value of y is. So we'll say 20 plus 12, that's 32, 40, 44. So we'll have 44 plus 4y. That's our summation of wx. So that the summation of w will be 20. Now, in that case, remember that our weighted arithmetic mean is equal to, we have summation of our wixi, as our I goes from 1 to n, all over summation of wi. So this will imply that since we're informed that the GPA is equal to 3, it will mean that this is 3, and that will be equal to the whole of this numerator is what we computed as what? 44 plus 4y all over. Now the denominator is what we have here as 20. Okay, so the denominator is 20. So What we will do is to multiply 20 by both sides. So we'll have 3 into 20 will be equal to 44 plus 4y all over 20. All of that times 20. So we'll multiply 20 by this and also 20 by this. Okay? So that 20 will cancel this 20. 3 times 20 will be 60 is equal to, we have 44 plus 4y. That is this 44 plus 4y. This already cancelled this. And if that happens, if you move this to this, you will have 60. In fact, this is exactly, say, in order to remove this 50, you want to make, now what we do here is to make y the subject. So we're taking the terms containing y to one side and the non-y term to another side. And so we have this 60 is this. So we are going to subtract 44 from both sides. So if the 60 minus 44 will be equal to this 44 minus 44 plus 4y. So 44 minus 44 will already be 0. And then 60 minus 44 will be what? Will be 16. So 16 is equal to 4y. If 16 is equal to 4y, it implies that 4y is also equal to 16. That's if A is equal to B, then B is equal to A. And so if 4y is equal to 16, it will mean that, and let me do this, if 4y is equal to 16, so it will be 4y all over 4 is equal to 16 all over 4. So 4 will cancel 4, we are left with y, and that will be equal to. Now, 4 here, 1, 4 will go into 16, and then we'll have 4. So y is equal to 4. So it means that the value of this y is 4. So if y is equal to 4, it means that the student, y is equal to b. It means the student scored b in the examination. We said, remember the question said, what is the score of the student in statistics? So since we've computed y as 4, it means that we know that 4 is equal to b. Therefore, the student scored b. Thank you, and God bless you. Do well to subscribe to our channel. Do well to share our videos with your friends. Like our videos so that we'll be able to do more videos for you. Thank you.